Okay, in this video, we are going to go over Descartes' rule of signs. It's definitely looks way more complicated than it is, but let's begin. So it says let p of x be a polynomial with real coefficients and a non-zero constant. So the constant at the end is a number and it's not zero. They're real coefficients. You don't have imaginary numbers. And it says the number of positive real roots is either the same as number of sign changes for the function or multiple of 2 less than step 1. Again, it's going to make more sense when we do a problem. And it says if, for example, you get 5 variations, then you could have, 2 less than step 1. So 2 less is 3, 2 less of that is 1, and you can't have a negative. Now, if you had 4 variations, it could be 4, it could be 2, it could be 0, because you could subtract 2, you could subtract 2. The number of negative real roots, there's a different formula. It says same as number of sign changes for p parentheses negative x. So you're going to put a negative x for the original equation, and then it's going to be the exact same thing as what we did here. And so what Descartes' rule of signs does, it doesn't tell us the actual roots. It just tells us a number of positive real roots you're expected to have or the number of negative real roots you're expected to have. And we're going to solve 2 problems. This will be the first one. So to get the number of positive roots, we have to see the number of sign changes. So going from 2 to 3 is not a sign change. Going from 3 to 4 is not a sign change. Going from a positive to a negative is a sign change. So we're counting only 1. So for the first piece, the number of positive real roots will be 1. And we can write that down. Number of positive real roots will be 1. And let's look back at our procedure. So the number of positive real roots is either same as number of sign changes for the function, which we did, we got 1, or multiple of 2 less than step 1. The problem is if you have 1, you subtract 2, you get negative 1. You can't have a negative, so you have to stop at 1. Now if you had a 2, for example, you could go down by 2 and you get 0. But 1 and you subtract 2, you get negative 1, and you can't have that. So the number of positive real roots for our problem was just going to be positive 1. And now we're going to do number of negative real roots. And for that, we have to do a different equation. It's p parentheses negative x. So wherever you see an x, replace it with a negative x. So we'll get 2 parentheses negative x raised to 3 plus 3 parentheses negative x squared plus 4 parentheses negative x minus 5. A negative x times a negative x times a negative x is a negative x cubed, so we get negative 2x cubed. Negative x times a negative x is a positive x squared, so positive 3x squared. A 4 times a negative x is a negative 4x, and we have a negative 5. And now we're going to do the exact same thing. We're going to count our variations, so we went from a negative to a positive, that's 1. We went from a positive to a negative, that's another 1. And so we have 1, 2. So we have 2. So the number of negative real roots will be, let me write this down, number of negative real roots will be 2, or, this one there is an or because we're counting 2, 1, 2, same as number of sign changes for p parentheses negative x, we got 2, or multiple of 2 less than step 1. So you can have 2, and then you can subtract 2 and you would get 0. So, or 0. And this right here is our final answer. So again, using this whole Descartes rule of signs, we came up with 1 positive real root and 2 or 0 negative real roots. Okay, this will be our next problem. If you want to pause the video and attempt it, feel free. So let's do positive first. So we went from negative to positive, that's 1. We went from positive to negative, that's 2. We went from negative to positive, that's 3. Positive doesn't count. Positive to negative counts, and negative to positive counts. So we have 1, 2, 3, 4, 5. So number of positive real roots will be 5, or, so we got 5. And then we got to say multiple of 2 less than step 1. So we can have 3, we can have 1. So we can say 5 or 3 or 1. This is for our positive real roots. And next we have to do negative. So we take our original equation and we put a negative in for x. And let's see what we get. Negative 4 parentheses negative x raised to 6 plus 2 parentheses negative x raised to 5 minus parentheses negative x raised to 4 plus 2 parentheses negative x raised to 3 plus 3 parentheses negative x squared minus 4 parentheses negative x plus 5. Okay, let's rewrite this to one line. Negative 4, negative x raised to 6. This is an even power, so we'll get a positive x raised to 6. This negative in front, it was already in front, so it stays. Negative x raised to 5 is odd, so this is going to become a negative 2x to the 5th. A negative x to the 4th, this becomes positive, but you have a negative in the front, so it becomes negative x to the 4th. A negative x cubed, odd, so you'll get a negative 2x cubed. Negative x squared, it's even here, so you'll get a positive, and this is already positive, so it will remain positive. Negative 4 times a negative 1x is going to be positive 4x, and we have a positive 5. And now we're going to do the exact same thing. So all of this was negative, here's positive, so from a negative to a positive, that's 1, and then the rest was positive. So number of negative real root will be 1. You can do negative 1, so it's just going to be 1. That's pretty much it regarding Descartes' rule of signs.